How do control systems stabilize the power grid? Imagine a busy highway where cars need to keep moving smoothly without crashes or traffic jams. The power grid works the same way, constantly balancing electricity supply and demand. Control systems act like traffic controllers, making sure everything runs without a hitch. They keep the frequency of electricity at a steady 50 or 60 hertz, which is essential for all your devices to work properly. When demand suddenly spikes or drops, these systems detect the change immediately. They then adjust how much power generators produce to keep the frequency stable. This quick response is called primary frequency control, and it acts within seconds to prevent big problems. After that, secondary frequency control fine-tunes the system over minutes to restore the exact frequency. Voltage levels are also important, like pressure in a water pipe. Control systems regulate reactive power using devices like capacitor banks and flexible transmission systems. This keeps voltage within safe limits, preventing equipment damage or outages. Inertia is another key factor. Traditional power plants with large spinning turbines act like flywheels, resisting sudden changes in frequency. When the grid faces disturbances, these turbines absorb shocks, giving control systems time to react. But with more renewable energy sources like solar and wind, which lack physical inertia, the grid becomes more fragile. To fix this, control algorithms create virtual inertia, mimicking the behavior of spinning turbines. These algorithms help stabilize frequency even when traditional inertia is missing. When faults happen, such as short circuits, control systems respond by injecting high currents to ride through the disturbance. They also manage load shedding, which means disconnecting some consumers temporarily if the supply cannot meet demand. Modern control strategies use data from sensors, machine learning, and networked control to adapt quickly to changing conditions. These systems coordinate generators, energy storage, and demand response devices to keep the grid stable all the time. Mechanical engineers play a vital role here by designing the physical parts like rotating generators and control algorithms that keep everything balanced. They ensure the system responds accurately and reliably, even as the energy landscape evolves with more renewable sources. So, control systems are the unseen heroes that keep your lights on and your appliances running smoothly, no matter what surprises the power grid faces.